Hi there, thanks for joining us. This is Space Nuts, where we talk astronomy and space science and sometimes recipes and wallpaper design. Coming up on this episode, we're going to be talking about zebrafish in space. Yep, they're up there, they're orbiting, they're making crucial decisions. And we're going to find out why. We're also going to look at the cold spot in space. It's part of the cosmic microwave background radiation, but why is it there and what's it doing? That is the $64,000 question. And we'll talk about a few other things as well coming up on this episode of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And once again, we're joined by Professor Fred Watson, astronomer at large. Hello, Fred.
Hello, Andrew. How are you How are you today?
I'm cold. The weather's really starting to chill down in my part of the world, which is not my favourite time of the year, but it's not even winter yet, but we've just hit a bit of a cold patch. We must be in the middle of the cosmic microwave background radiation, because it's something Kelvin here at the moment.
I think you hit 1 degree last night, didn't you? I saw it on the
something
forecast.
like that.
Yes.
Yeah. It's a lot of people think that the West is just a hot dustpan, but in winter it is definitely not that. We get some very cold nights here, but people in North America are probably going, oh, yeah, you don't know what cold is. No, I don't. I don't want to find out. That's all good and well. Fred, before we get into your topics, I just wanted to bring something up because we've talked about this before, and there's been an announcement made this week that the 3200 megapixel legacy survey of space and time camera that was being built for the Vera C Rubin telescope has been delivered. They finished making it in April, and then it's been flown by 747 cargo plane to its location, and it's now been delivered to the telescope. So they're really getting to the pointy end of this project. What intrigues me about this is that it's the biggest digital camera that's ever been produced, 3200 megapixels, and it is super duper sensitive. And it will be able to take a very wide field view. I think its observing power is 7 times that of the width of a full moon.
Yes, that's right.
Amazing.
Yeah. So a full moon's half a degree across. So what that's telling you is 3.5 degrees field of view, which is extraordinary for a telescope that size. It's an 8.4-meter telescope, which is going to survey the whole sky, I think every 5 nights or 3 nights or something ridiculous like that, looking for things that change. It's transient astronomy, as it's called. And
I think I read the term time lapse. They're going to do a 10-year time lapse of the southern sky.
Yeah, that's right.
What you could learn from that might be just amazing, because we just see the sky in real time, and it's so easy to miss things, I would imagine.
Yeah, so principally what they'll be looking at is things that move, and that means it's going to net thousands and thousands of asteroids. Possibly the more distant ones, it'll probably discover, Kuiper Belt objects. May even find Planet 9, actually. It's probably one of the best potential tools for finding Planet 9, if Planet 9 exists. But also things that change in brightness, exploding stars, anything that kind of goes bump in the night, it'll pick up because of that cadence of, observing the whole sky every few nights. It's a remarkable machine. I was looking at a picture. Another announcement that you might have missed that came from it about 3 weeks ago was that they've just put the coating on the main mirror. The main mirror, as I said, 8.4 meter in diameter, but it's a very unusual mirror because it's dished like all telescope mirrors are, but there's a section in the middle which is sort of probably more than half the diameter of the mirror, which has a different curvature. So it's like a double dish. It is really quite extraordinary to look at. If anybody feels like Googling that, look for surface coating of Vera C Rubin telescope mirror or something like that, and you'll see a marvelous picture of this strange double dish mirror. And it's like that because the light from the stars hits the outer part of the mirror, is reflected back then to a second mirror, and then hits the main mirror again, but in a different part. So the different curvature focuses it in a different way. It's a very intriguing design of instrument. Yeah. Quite different from the normal.
Yeah. I knew you'd know all about it because I know you're just so into telescopes. And you've written a book about telescopes and how they all came about.
Yes, I did.
You did, yes. And when I spotted that story, I thought I'll just have to bring that up with Fred because he'll probably know the guff on it. But with the camera now being delivered, they're getting really close to commissioning this telescope. My only thought is like it's going to be a ground-based telescope, but I'm guessing that this is going to be at such an altitude that atmosphere is not going to be as big a factor as it is in other parts of the world.
It's a good site, that's right. It's in. It's not that far from La Serena in Chile. I've seen it actually from across the other side of the valley. I haven't visited the site, but I've seen it, and it shares that. That's the dog. It shares that site. Johnny's seen it too. Sorry, everybody. It shares the site with the Gemini South telescope as well, which is another 8-meter telescope, but one that doesn't have that same field of view. So yes, an extraordinary instrument. It's been a long time in gestation, has that telescope. We've been talking about it for many, many years, but it's now very near to fruition. And Australian astronomers have got a bit of a toe in the door because we've got to deal with the observatory that allows us to analyse the data and look at some of the stuff that's coming off it. So there might be Australian discoveries made from that telescope as well.
We can only hope so, and we will certainly be keeping an eye on this, and we'll talk about it when it gets up and running, whenever that will be. In astronomical terms, could be another 25 years. No, it won't be that long, but
25 million years sometimes.
Maybe. From the world's biggest camera to some of the world's smallest astronauts, we're talking Zebrafish in space, or aquanauts, maybe they are. But these are zebrafish that are on a Chinese mission. What's this all about, Fred, and how did they make the helmets so small?
It's about research. This is research taking place on Tiangong, a space station, the Chinese space station. Tiangong, of course, means Heavenly Palace. It's a lovely name for what is quite an able and certainly pretty efficient and effective piece of kit. It's about a third the size of the International Space Station, so nowhere near as big, but more modern in many ways.
But they've got 500 people in there.
I won't touch that one either. I think they're standard crew is 3. I think that is correct. But of course, there are experiments going on that spacecraft, just as there are on the International Space Station. And one of them is to look at the effect of space on fish, and in particular, these zebrafish. 4 of them. I'm sure they've all got names, which are apparently doing really well. Except they don't know which way up to swim, as you'd kind of expect, because they won't be feeling the gravity, so they're swimming upside down and things of that sort. But analysis is being done. And one thing I didn't know is that the zebrafish apparently have genetic similarity to humans.
I'm gobsmacked by that. I mean. Yeah. It doesn't surprise me that we're, only a couple of degrees away from a mountain gorilla, but to have an anatomical similarity to the zebrafish.
I don't know that it's quite anatomical, but it is certainly when you look at the gene, the genetic makeup, there are genes in common, and that's why they've chosen zebrafish, because it's a model for perhaps seeing what the effects of space are on the zebrafish that might correlate with some of the things that we know happen to humans and maybe lead to treatments and things of that sort that we could use here on Earth. So, yes, very, very interesting. They're calling them...
I used to... Sorry, go on.
I was just going to say they're calling them aquastronauts. Because aquastronauts, I can't say it, because they're aquatic, I guess. Go for it, Andrew.
Yeah. I used to keep zebrafish when I had fish in my house. I used to love keeping fish. I had several aquariums over the years.
That's interesting.
And zebrafish were great. They were a schooling fish, so if you got enough of them, it just looked really good in the fish tank with all these fish sort of swimming around, seemingly aimlessly, but they all clustered together. I cleaned the tank out once, and I was just about to dump the rubbish, and I saw something moving in the bottom of the bucket, and I picked it. I actually captured it with a straw. I put the straw over it, and then somehow managed to create a suction effect by squeezing the straw, and caught this thing and put it in a jar. Didn't know what it was, but it was about the size of an eyelash.
Oh wow!
And it grew into a zebrafish.
Oh, isn't that extraordinary? The baby zebrafish.
Yep. So it makes me wonder how many I sucked down the toilet. But anyway.
Yeah, that's right.
He grew into or he or she grew into a reasonable size until another fish went, oh, yummy lunch.
Oh, really?
I'm pretty sure that's what happened to him because he disappeared.
Yes, that's...
But it was pretty exciting. But they are prolific breeders, and that's one of the things they're going to be looking at is the effect of zero gravity on their eggs and everything else. It's it's really interesting stuff.
It is.
But we've had so many different creatures in space, like spiders, and they've had ants. They've done ant colonies in space, and of course we've had dogs in space, and a few other things.
This is not the first fish in space.
I didn't think so.
That goes back to 1973, in fact, when Skylab had experiments on board which used fish. I would call them gudgeons, but I think they've got different names in different parts of the world.
Mud skippers, something like that.
Yeah, that's right. And they, so that was quite successful as well. And I think there've been other experiments. I think actually on the Apollo Soyuz missions there were fish as well. So it's, I mean, you kind of wonder whether they ever end up with chips on a plate or something like that, but probably not.
I was going to say that the first fish in space was a beautiful salmon steak, but
maybe
I don't know if that's true. You mentioned gudgeons. There's a specific gudgeon from our part of the world that's endangered. And I remember they were doing a lot of work to try and restore its numbers in the Murray-Darling Basin, and it was the purple spotted gudgeon, I think.
Yeah,
quite striking actually when you get up close to them. They've got these bright purple spots on them. They're amazing. It's a strange fish because it lives in and out of the water, and it's one of those things that is halfway between a sea creature and a land creature, or an aquatic creature and a land creature in the evolutionary scale. It's quite amazing. So it doesn't surprise me they've had those in space. But zebrafish, that kind of came out of left field. But it sounds like their DNA makeup is a good reason to have them there, because we can learn a lot about what happens to them and thus maybe what happens to us. I don't know. It's all part of a process, isn't it, Fred?
Indeed, that's right. Yeah, so we'll follow their progress with interest. If there's any news about the zebrafish down the track, it will come to you via Space Notes.
Oh, and one thing that I also wanted that I read about that story is that they're trying to make these aquariums in space self-sustaining.
Yes, that's right.
I think that's another experiment. They want to see if they can just sort of be in that environment and you don't have to do anything with them. They'll look after themselves long term, which is another thing we'll have to do as human beings if we're going to do long-term space travel.
Yeah. Although I did note that they've had to replace the food box on the aquarium tank.
Yeah. The only problem with this theory is that humans can't hold their breath for that long. So
Yeah. Well,
No.
that's right. I mean, you touched on something that I just once wrote about you've really got to make anything that's going to involve long term um, uh, visits to space has to be self-sustaining.
All right. If you would like to chase up that story about zebrafish, you can check out the spacedaily.com website. This is Space Nuts. Andrew Dunkley here with Professor Fred Watson.
Okay, we checked all 4 systems and skiing with a go.
Space Nuts.
Our next story, Fred, is a bit of a mystery. There's a cold spot in space, and it's got something to do with cosmic microwave background radiation. And the reason I say it's a mystery is because they're not sure why it exists. Is that where we're going with this?
Yes, that's it in a nutshell, Andrew. So let's just revisit the cosmic microwave background radiation, that microwave hiss that is all over the sky. It's over the entire sky, discovered by Penzias and Wilson back in the 1960s, and because they realized, or it was realized, that what we were seeing was the Big Bang, the flash of the Big Bang, at a look back time of 13.8 billion years, as we now know. It's been a very important asset. And the thing about the cosmic microwave background radiation, and this was predicted back in the early days, when it was just discovered as a kind of hiss in microwave telescopes. It's got temperature variations in it. It's got slight changes in intensity as you look at it. So there's a sort of pattern there. And that also was predicted, because without that pattern of hot, warm and cold spots, we wouldn't exist. The galaxies wouldn't have formed. There would not be structure in the universe. So that was a big discovery made. It was Geoffrey Burbidge who suggested that. I might be fingering the wrong astronomer, but it was certainly a discovery made back in the time before we'd even got the wherewithal to measure that unevenness. The technical term for the unevenness of the cosmic microwave background radiation is anisotropy. When something's isotropic, it is the same in all directions. When it's anisotropic, it's not. And that's what the cosmic microwave background radiation is. So measurements of the anisotropy of the cosmic microwave background radiation have been carried out by 3 major space missions. COBE back in the day, 1990s Cosmic Background Explorer, that produced the first maps. And then we realized that we could learn much more if we had a finer resolution. Rather than looking just at big blobs on the sky, could you break them down into finer detail? So WMAP was launched around about the turn of the century, I think, if I remember rightly. WMAP was the Wilkinson Microwave Anisotropy Probe, and then finally the Planck spacecraft, PLANCK, which was sent into orbit by the Europeans, and that's given us the finest detailed maps of the cosmic microwave background radiation. All of that has pointed, though, to cold spots, and in particular one cold spot that's bigger than the rest and actually colder than the rest. So it's quite extraordinary how small the variations in temperature are. They're, in the region of 10 to the minus 5 of a degree. And so you're looking at very, very fine details. It's, 1 part per million is really the kind of level at which there is variation. And I should say that the average temperature of that cosmic microwave background radiation is 2.7 degrees Kelvin, roughly 3 degrees Kelvin. So minus 270 degrees Celsius, very near absolute zero.
Yeah.
That is the backstory. What we're talking about now, though, is, and this was discovered probably quite early on in the history of our mapping of the cosmic microwave background radiation, nearly 30 years ago. It's a spot that is bigger and colder than the average. And so there's a few statistics that are given by a very nice article about this on space.com, which our listeners might want to have a look at. If you think about the average cold spot on the cosmic microwave background radiation, it's about 18 microkelvins colder than average. A microkelvin is a millionth of a degree Kelvin, which is effectively the same as a degree Celsius in that scale. So 18 micro degrees colder. But this one is kind of getting on for 10 times that. It's 140. Wait a minute. No, it's much more. It's much more. I've misread that because it's millikelvins. 140 millikelvins colder than average.
Wow.
Yeah. So that's nearly 10,000 times colder than the cold spot, the average cold spot. And it's also, as I said, it's big. It's 5 degrees. We've just had a conversation about the field of view of the Vera C Rubin telescope, which is smaller than that. But it's a big field of view. It's 3.5 degrees, but 5 degrees is a colossal size on the sky. So it's cold and it's big, and that's very, very interesting in what it is telling us. You kind of expect to. Occasionally there'll be outliers of any distribution of things based on their size or the temperature or whatever. You're going to have outliers which will be much more distinct from the general levels. However, the chances of this being random are apparently less than 1%, and maybe even lower. And so there is thought as to the fact that there's a reason for this. And excuse me, there is a kind of explanation which is a bit complicated. I might read, actually, if space.com will forgive me, I will credit this to them and read the article. Who's the author? It's Paul Suter, who's very, very able writer on this kind of science. Let me just quote from Paul's article. He says the favoured explanation for this strange cold spot is that it's due to a giant cosmic void sitting between us and the cosmic microwave background radiation in that direction. Cosmic voids are big patches of almost nothing, and we know they exist. Just an aside from me, we see that kind of structure in the wider universe. What we call the cosmic web is a network, honeycomb of galaxies with not much in the spaces between them, a kind of honeycomb space. And so that is perhaps one theory. And what then imprints that a signal from that void on to the cosmic microwave background radiation, as pointed out by Paul in his article, they influence the cosmic microwave background light, and that's because those voids are evolving. It's changing because the universe is a movable feast. The universe has motion. Everything's moving in the universe. And so these voids are changing. So I'm quoting Paul here. There's a really good paragraph that explains this very nicely. When light from the CMB first enters a void, it gains a little energy as it transitions from a high density to a low density environment. In a perfectly static universe, the light would lose an equivalent amount of energy when it exited the other side. But because the voids are changing, when the light first enters, the void might be relatively small and shallow, and by the time it leaves, the void is big and deep. This leads to an overall loss of energy, the energy of the cosmic microwave background light crossing the void, a process known as the integrated Sachs-Wolf effect, or Sachs-Wolfer is probably how you should pronounce it, but we call it Sachs-Wolf. So check that out online. The integrated Sachs-Wolf effect is this loss of energy in an evolving system. There's one final mystery here, Andrew. I'm sorry, this is a long, complicated story.
No, that's okay.
Yeah, but we don't see a void there. Because, we've got these galaxy surveys, which I've been involved with on the Anglo-Australian telescope and the UK Schmidt telescope. These are surveys that show us where the galaxies are distributed and give you a map in 3 dimensions of what the structure of the universe is like, as marked out by galaxies. And yes, there are voids there, this honeycomb effect I was talking about. The direction of this cold spot doesn't have an obvious void. Some researchers are saying, well, yes, our surveys are not complete, and that's certainly true. Incompleteness is one of the big banes of any studies that are based on these galaxy surveys. But there are, there's research. Some researchers have said, "Oh well, we think we've seen a void, or a super void, as it might be called." So yes,
like the Bortes void. Did I pronounce it correctly this time?
Yes, that's right. Yeah. This is one of the mysteries that we're going to have to leave as a mystery, I think, because nobody really knows what's happening, and it may be that this is something.
So what we're saying here is that cold spots in the cosmic microwave background radiation are not unusual, but this is a bigger and much colder spot, and it doesn't appear to be associated with a void like all the others, or most of the others.
That's correct. Yes, that's right. So there's something spooky about it, but we don't know what it is.
It's that's bigger and weirder than you could imagine, and that's how they describe it in the article: bigger, weirdly bigger, and weirdly colder.
Yes, that's right.
Which is scientific speak.
It is. Well, that's right. When it's weirdly, you're really on the edge of knowledge there.
I suppose, obviously the goal is to solve this. I wonder what we learn if we do solve it. There'd be something to learn, surely.
Oh, there would. Yeah, that's right. There would indeed. It does challenge, though, the notion that the universe is the same in all directions, which is a kind of fundamental tenet of cosmology. We know there are galaxies and clusters of galaxies and things like that in various different directions, but when you average it over the whole universe, effectively it's the same in all directions. That's the isotropic thing that I was talking about. That's what we assume is the case, and so most cosmological theories of the origin of the universe are based on that idea. And if that's wrong, then I've got to look at it.
Yeah, I've got a rudimentary idea in my head, which is probably way wrong. But when I was a kid, I used to go and swim in the reservoir up behind our house, and you'd swim through warm patches and then you'd hit a cold patch. Is that what the universe is like?
Yep, maybe. I do remember that when I used to swim back in the day as well. And it would be all to do with just the thermodynamics of what was going on in the pool, whether one bit was in the shade of trees or one bit was deeper,
and the water rotating through cycles of heat and cold.
But that's true. You'd very notice it, even probably only a degree or so. You'd notice. You think, oh gosh, that's a cold bit there. Yeah.
Well, we used to notice it because it would be beautiful and warm, and then you just swim. It's like swimming through some kind of membrane, and suddenly it's freezing cold. It was very strange. Very strange. All right. As Fred said, if you'd like to find out more about that strange cold spot in the cosmic microwave background radiation, it's space.com. And great website and brilliantly written articles they publish as well. Fred, that's brought us to the end. I just remind people, if you're a YouTube follower, don't forget to subscribe below, and don't forget about our website if you'd like to visit us and check out what we've got on offer there, spacenutspodcast.com or spacenuts.io. You can subscribe to the Astronomy Daily newsletter. Don't forget about our Astronomy Daily podcast as well, with Steve, my brother, one of the hosts, and plenty more on our website, spacenutspodcast.com. Thanks, Fred. We'll catch you again real soon.
I hope so. I'm looking forward to the next time. There's so much going on in the world of space.
There is indeed. You never stop learning or wondering what you can learn. Thanks, Fred. We'll see you soon. Fred Watson, astronomer at large, and thanks to Hugh in the studio, who's having breakfast at the moment and can't talk. And from me, Andrew Dunkley, thanks for your company. Catch you on the very next episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.